All right, in this example, we're going to look at calculating our pH when we go beyond equivalence. So in this example, we have ethanoic acid, which is a weak acid, and it's being titrated with sodium hydroxide, which is a strong base. We have added 60 milliliters of sodium hydroxide. That seems a lot compared to my 20 milliliters of my weak acid. I know that all of my weak acid will be completely consumed, and what's left over in the solution will be my sodium hydroxide. To solve this question, I'm first going to start with calculating the moles of my acid. What was given to me for my moles of my acid is 0.020 liters times 0.6 moles per 1 liter. I have 0.012 moles of my acid. At my equivalence point, my moles of my acid are going to be equal to my moles of my base, and I can calculate the volume that I needed to get to this amount of moles using my concentration of my base. My volume of NaOH is equal to 0.012 moles of my acid. For every 1 mole of my acid, HA, I have 1 mole of NaOH. For every 0.300 moles of NaOH, I have 1 liter. This tells me that I needed 0.040 liters to reach my equivalence point where my moles of my acid are the same as my moles of my base. To calculate my extra volume of my base, I'm going to say V extra is equal to 0.060 minus what I needed to reach my equivalence, 0.040 liters. I have remaining in my solution 0.2 liters. Now I want to find the moles of my base with the extra volume left in the solution. I have 0.020 liters left in my solution, and my concentration hasn't changed from 0.300 moles per 1 liter. This gives me a new amount of moles, 6.0 times 10 to the negative 3 moles of NaOH. The total volume of my solution is now the 60 milliliters plus the 20 milliliters that I started with of my acid and my base. I need to calculate this so I can find the new concentration of my base. I have a new amount of moles that's left when I have that 20 liters left over, and I have to take into consideration that I have 80 milliliters in total in my solution. This gives me a concentration of 0.075 moles per liter. In sodium hydroxide, when I dissociate, I turn into sodium ions and hydroxide ions, meaning that for every sodium hydroxide formula unit, I will have 1 hydroxide ion. Remember that sodium hydroxide is a strong base. It does not exist in equilibrium when we put it into water. It will go completely into sodium ions and hydroxide ions, meaning that if I have 0.075 moles per liter of my NaOH, I now have 0.075 moles per liter of hydroxide. I can calculate my pOH with this concentration. I have 2 significant digits here. This will turn into 2 decimal places. When I complete this calculation, I will have 1.12 as my pOH. To get my pH, I will take 14 minus 1.12, leaving me with 12.88. And then I will smile.